Hey everyone. Okay. All right. Chat box is open. Whatever you got for questions along the way, let me know and try to make it through the end of this one and end the P word discussion before you go on fall break. So we're here, right? We have a few more days before anything is due, October 9th, and then a few more days, October 14th, and the research topic is due. That's your one sentence um, just a research title. Lab 2 is eventually going to be due. The exam right on the 21st. Some readings so far, not that many if you feel like doing them. I just remember I talk about all of the book stuff that is going to be on the test will be in the slides somewhere. You've seen my test before, a test at least before, so you know what kind of content I'm going to put in there. The due dates for stuff that's coming up. Just remember the executive summary that everyone submits their own with those and acquire meaningful data, right? So whether you capture it yourself or you just go grab somebody else's, some publicly accessible database, something that we have here on campus, epidemiological databases on the internet, or I'll teach you how to do um, if you want to do like survey monkey questions and just send them around to the class, something like that, that's okay too. But you would want to get more people than just in the class. You'd want to send it out to others as well. For the CD certification, in the last few lectures, I had that link to the CD certification page and stuff. You know where to find that. But what you actually send me, you'll register for the thing, make sure it's free. Nobody's allowed to spend $1 on this. The university pays for it. Sometimes people will start signing up and then realize that it's asking me for a credit card. Don't let it do that. Register through the university for the CD certification. And this looks like Juan Ramirez. He got 100%, so I can put his in there without embarrassing him. But that's what you'll send me is the completion report. And normally what people get, if you look at the very last one, um, he got a 5 out of 5 on the very last one. But the last one you can't redo. All of the earlier modules you can just submit, and then it tells you what the answers were, and you just redo the module. There's a bunch of different questions they can draw from, but there's like 8 questions, and they'll ask you 5 of the 8 or something. So it's not like a normal test in class where you get to submit the answer and realize you got it wrong, learn what the correct answer is, and then retake that question. Like this is the CCERT. It's not as hard as anything in life. It's just a little bit time consuming, so don't put it off until the last day because they'll be pissed. Choosing your topic, right? So the purpose of this is just to discover something. It doesn't have to be huge. It doesn't have to be, it has to be interesting, but it doesn't have to be groundbreaking or whatever. And then just demonstrate its truth, or its probability, at least the probability of its truth using statistics. So a possible question that you could ask if you wanted to collect your own data using SurveyMonkey, we have access to that, but it's a little access code, and we have to go through Miguel, and he has to sign you up. So you can't just use it. I want to use SurveyMonkey, and then an hour later using it, you have to wait for some correspondence to go through. But how does choice of residence, how far away you live from the university, affect your scholarship, affect your grades, affect whatever it is about student scholarship that you care about? And some people live at home with their parents. Some people live here in the city somewhere. Other people live on campus. I don't know how many people this semester, if anybody on campus this semester, but people have these different distances of residence, how far it takes them to commute. And so the dependent variable, the outcome for this question could be GPA, either a single semester, right? It could be at graduation, what was your cumulative GPA, your overall GPA? It could be Um, some standardized testing, right? It could be the SATs or GREs or something. It could be number of semesters it took to graduate, or whether somebody graduates, a dichotomous, a binary outcome at the end, yes or no, did the student graduate or make it through to the end? So that would be your dependent variable, would be student scholarship, however you define it, but the definition should have some understanding. It should have some clarity, some specificity. The independent variables, ideally you'd have a bunch, whether people live on or off campus, right? If you live on campus, does that mean you're in the library all the time and access to office hours? And this semester doesn't make any sense, but in life in general, a normal semester when you're actually on campus, would that mean that you have access to those resources and so there are fewer barriers for scholarship? Or would it mean there's too many social things and so you would rather do the social engagements and stop participating in scholarship? Maybe run the stats. Let's see. Do you have a parking pass? How old are you? Male versus female? You'd want to collect a ton of data as independent variables. Does the person have a job, right? That would affect the GPA. So think about confounding variables. If somebody has a 20-hour week job and they're going to school for 16 credits or something, that's a lot of commitment. Few hours of sleep at night, additional stress, that allostatic load, how much total stress can be summed on your life. Throw a marriage in there and a kid or something, and you got even more stress in your life. And maybe it depends on the marriage and it depends on the kid, but you would want to collect as much information as you can. If this is the type of question you're going to do, just think of all potential confounding variables so you can control for them. You could also ask something about how does athletic participation affect GPA? You could do, are you an athlete versus are you not an athlete? Just a basic t-test, independent samples t-test. And that would be a very crude way of looking at it, this very basic, unrefined, just blunt way of answering that question. You could do a paired samples t-test where you say, well, in season and off season. So I'm playing the sport for whatever months, and I'm not playing as much in this semester, and look at one particular athlete's not one athlete, but look at the individual athlete's time course in grades and compare their on seasons to their off seasons. But you would want a bunch of independent variables for that too. The major is going to matter. If someone's bio versus someone's communications, like this is a massive difference in GPA. And so you'd want to hold those things constant. So just tons of questions you could ask. Just find something that's interesting to you. Doing research that you're not interested in is an exercise in pain. I mean, that's just agony and boredom and frustration. There's nothing good comes out of doing research you don't want to do, or doing really anything that you're uninterested in. So sleep schedule. Have somebody have people track their sleep, wear a Fitbit to bed, and see if that is affecting athletic or academic performance. If sedentary students begin exercising, does that matter? I have a database on Bond Fitness Center about, I think his graduation rates, I can't remember what it was on, but use for Bond Fitness Center, and it at least had predictors of if people exercise X amount of days a week, they're X% more likely to use the rock wall, X% more likely to do club sports or whatever. And so just come up with a meaningful question. It can be about anything that's interesting to you. As soon as you have your question, right, do your background reading on it. You can start with some Wikipedia and Google, fine, but really for your citations, go through PubMed is going to be best. And you can cite as many things as you want. You can read as many things as you want, but at least get one good meta-analysis in there or systematic review if you have access to them. If that has been published before, that's going to be best. And the quality of these things should aim to adhere to the Prisma guidelines. This is the Prisma guidelines. You don't need to know them. I'm not going to test you on them. This is just if for people doing meta-analyses, this is we're talking about the quality of data. That's all this is. So once you have some passable mastery over your topic, right? You've been researching this thing, you've been reading about it in a systematic review or meta-analysis. Then you write your executive summary, which is eventually due, and then build your database, and you're going to analyze it in SPSS. This is an old exam because we don't really have office hours to the same extent this year. I guess I could have done it with digital office hours or something, but every semester I teach this class, I analyze a ton of stuff. And so this is a t-test, this is independent samples t-test, the exam grade. Did people go to my office hours? No or yes. And it was about evenly split-ish. Fewer people went to my office hours, but the people who went to my office hours had a much higher, an 8% higher score on the exam with a big standard deviation. And it does meet Levine's test of quality of variances. So we can look at that top number and say, that's pretty significant. Does it meet that 0.05 line in the concrete? What Fisher said was, I like the idea of 95%, but I'm not going to stick to it for every single experiment. And then the world accepted that as law, and nobody will ever update that. I hope people eventually do. But it doesn't quite meet significance. So you say a very strong trend, but what significance means, remember, you have to start with that if the null hypothesis is true. If the null hypothesis is true, meaning office hours don't matter, they don't affect your grade, go to office hours, skip office hours, your grade is unaffected. If the null hypothesis is true, there is a 5.3% chance that we would have observed in this particular class a grade difference of 8% or something more extreme than that between the office hours and the non-office hour folk. Now, something else to consider is the type of person who, remember I keep talking about that when we were doing epidemiology in 20th century and 21st century, of the type of person who, maybe the type of person who goes to office hours is also the type of person who just studies more. Yeah, and so a t-test never really tells you all that much unless it's a randomized controlled trial. If you randomize people to office hours and non-office hours, if you randomize people to exercise interventions, now the t-test gets a little bit better. But from a epidemiological perspective of, you take a data set and you don't intervene, you don't randomize, you don't really control, and you just start separating groups, it gets a little bit weak. There's assumptions that you have to, like, well, the groups are probably evenly distributed, and it's never really true. It's better to control for things. And to control for things, you would do a linear regression. How does the type of people who tie into significance? Okay, so the type of people who has no effect on significance. Significance, the p-value, does not consider the type of people who. So this is one of those limitations of a p-value. For that McCann-Erickson, for everything else there's MasterCard campaign. For everything else there's a p-value, but yeah, the p-value, single most ubiquitous statistic you will ever encounter, the p-value. Now, I like a nice, unstandardized beta now and again. I mean, there's things I like, but the p-value is what you see every paper you pull up. If it's not qualitative sociology or something, there's p-values all over the place. Just every page has p-values on them. Maybe not in the introduction, but in the results and the conclusions, you're just seeing a bunch of p-values. And the p-value doesn't control for quality. So the type of people who, it does not get into that. The p-value does not care what types of subjects you have. So just remember the null hypothesis, type 1 error, type 2 error, easy questions to ask about on a test. And always, if the null hypothesis is true, that's how you always start the definition of a p-value, right? If there's no relationship between these variables, that's what you're saying. If this supplement has no effect, that's what you're saying. If the null hypothesis is true, then there is only a p-value % chance you would have observed something that you did, or more extreme than that, right? So either more negative or more positive. Now that 0.05 rule, people trying to justify it, as opposed to Ronald Fisher saying, oh, this is arbitrary. Nobody else needs to do this. It's just this 95% chance sounds like a good round number with a lot of confidence to it. People have come up with ways of rationalizing what is sort of arbitrary as this concrete law with reason and rationality. So just to confirm, the p-value is just addressing the unknown, like what we can't describe. Yeah, it's addressing the probability of finding something. So what are the chances that this would have arisen in an experimental condition if it weren't real? You know, if um, let's say people who live on campus have a zero point 0.2 higher GPA. It's 3.2 as opposed to 3. And you sampled 50 students to get that. You took a sample, 50 students out of a population, thousands of Pacific students, take a sample of 50, and on-campus students have a 0.2 GPA point increase over the off-campus students, and the p-value is 0.06. What you'd be saying is, well, if there is no difference, if we were to just take everybody, measure every single Pacific student who lives on and off campus and compare them, and there turns out there is no difference, there's only a 6% chance we would have observed what we did, 0.2, or something more extreme than that, 0.3, 0.4. Would you mind explaining it with the heads and tails thing too? So yeah, the heads and tails, it's sort of a bad example to illustrate p-values, but just the idea of what I said is a right and left hand. You could also do morning and night. You know, you could do my hand and your hand. I mean, you could do any number of comparisons, and it's 50-50, this thing. I mean, there is no difference. So what the p-value is saying is giving you a probability, but the p-value isn't telling you an absolute, you know, fact or the truth. It's giving you a probability of an outcome, a probability of finding the outcome that you did. Now, it doesn't say you're right or you're wrong. It's just a mathematical probability of eliciting the event that you found or the measurement that you detected. It's just a probability. So that gone fishing thing, that's just, it's a cliche. At some point in life, you'll hear it, oh, hunting expedition, you're on a fishing expedition. It's actually, that's how you want to do research, if people would think about the cliche that they're using. Where you make all of your decisions ahead of time, drop the lure in and see what happens, right? You don't want to just come up with your finding first and then come out with a way of you know, okay, here's what came out of the water, let me now decide how to fish this thing out. So internal validity, external validity. Remember, internal validity is soundness of your methods. It is how controlled your experiment is. Are you measuring what you think you're measuring? That's internal validity. You've trained your staff, you've calibrated your equipment, the subjects aren't super weird. You're measuring exactly what you think you're measuring. External validity is, can you generalize this thing? Is it relevant to a larger population, or can you only describe the tiniest, I only sampled people with Marfan syndrome who were over 10 feet tall. Okay, you can't talk about cardiovascular health and exercise in the ordinary person, in the average population, if your sample is 10 feet tall, you know, with a disease that potentially has cardiovascular implications, and the interaction with exercise could be compromised. So the generalizability, that's your external validity. And significance, just remember, these things, or statistics rather, these aren't organic components of life where you look outside and you see them kind of statistics growing through the sidewalk, kind of reclaiming you know, the built environment. And statistics are a human intervention. They are rife with bias, and your job is to be as unbiased as possible, be as cautious as possible. Now, caution doesn't always elicit caution, and ethics. These things don't elicit massive findings. You can take any data set and come up with something spectacular if you cheat, right? If you just mess with it a little bit and, oh, let me get rid of these subjects, let me selectively eliminate these subjects that don't agree with my hypothesis, and let me control for this thing that shouldn't matter, but there's an arbitrary effect that it has that really encourages my outcome, and you can come up with some mighty findings if, again, you do a bunch of gymnastics with it, if you contort your data and your analyses, and it's harder to contort your interpretations because other people can just look at your outputs and say, nope, they don't mean that. But the process of analysis, you can be pretty sneaky with it and do this sort of, bend yourself supine of trying to get your findings. And so just remember, from that perspective, garbage in, garbage out. If what's going in to a dish are these ingredients together, that doesn't go well together. If something's all like moldy and rancid and covered in maggots, good luck making that a delicious steak. I don't care what seasonings you have. That's not going to taste good when the maggots are cooked into it. And so you don't need to remember this particular study that I was involved with. It was a $5 million study, actually. It was an NIH, National Institutes of Health, R01 grant, the biggest kind of grant you can get. There were two different studies. One of them was HIV positive. One of them wasn't HIV positive. One was, I think, $1 million taxpayer money, right? So this is federally funded research. It was a huge study. Some of the publications were really good that came out of it. This one that they tried to do, I hope they never published it, because I don't know how the hell to code this stuff. Zumba or Stairmaster and go ahead and walk on mic for a while. I don't know how to code that stuff. So the data that I gave them, I mean, I admitted it. I was like, I don't know, maybe this is, give or take infinity. I have no idea what any of this means, but here's the best I could do with the information you gave me. Here's the best amount of caloric estimations that I could do. Okay, so some of you probably watched last night. It was kind of hysterical, the whole thing. Okay, there's a question. Doesn't population size also affect statistical significance? Yes. Population size, the sample size, affects statistical significance. The larger your sample, the more significant your finding, the more probable your outcome. And we'll talk about that in a little bit. But remember, there was that study that I was a reviewer on that had like thousands of people, and the average weight loss was essentially nothing. They lost 3 feathers worth of weight, but it was significant, because there was just thousands and thousands of subjects. So you're more and more confident if you see 1,000 people respond to a treatment. You're more confident than you are if 6 people do. If you have 6 people who respond to a drug or a supplement, you're like, oh, okay, maybe, yeah, we have 6 people, but that could be a fluke. I don't know. We have 6 people. We better test it on 100 more people before we're really sure. Like if there was a drug and they said, okay, I don't know, a brand new drug, it's on the market. Let's say it's like the COVID immunization, and they say, all right, 3 people have taken it, no one has died yet. You're not that confident yet. You want to wait for another 1,000 people to take it and say, okay, there are no adverse events. There's another 1,000 people have done this and nobody had an adverse event in the tiniest bit. Yeah, give it to me. And so it's the same thing with calculating these probabilities, where if you enroll 3,000 subjects, your p-value is going to be really confident, but it doesn't say anything about the magnitude of the effect. Magnitude is stuff like unstandardized beta, which is why I like that value better, but you have to look at them together. The confidence interval tends to be the best. A study with a large population will most likely find statistical significance. A small population will. True. They should have an option to move to Canada, and that's me. So a comment on the debate. It was just funny. It's just entertainment. It wasn't even political. It was just hilarious. But you look at the victory. It seems to this particular poll that people did seems to have gone to Joe Biden. And a lot of people thought it was a tie, but obviously it was just everybody who voted for Joe Biden here was a Democrat. Everybody who voted for Trump was Republican. And then these are the, Ohio's or whatever, these are your swing states. But does this matter? Do these polls matter? Because we saw this, right? So Jeb Bush was supposed to be the president, right? He was the one who had the most support at this time. Jeb Bush would beat Hillary 45-40. Hillary would beat Trump 42 or 44-42. But that didn't happen, right? So this is first, second, third, and it's the opposite order. And so the way some of this works now in politics, some people might openly say, oh, I would never vote for Trump, just because of whether it's, I don't want to get into political things, but let's just say there's particular elements of Trump's way of speaking or way of behaving, mannerisms or something that rub people the wrong way. They might say, "Oh, I would never vote for him publicly," and then, but when no one's looking, they'll vote. And so I think there are more errors to find in a presidential election than simple representative sampling, which is what this was. So definitely know this story because it's the best example in at least recorded history of representative sampling, probably the best example ever, because they had 2.3 million votes, 2.3 million not real votes for the election, but these just sort of trial. Let's just let me know. Let's do a little poll, cast a fake ballot, and let's see who's going to win. Alf Landon, right, by a landslide. Let's put an oil tycoon in the White House by a landslide, and then 3 days later, Roosevelt destroyed him with the biggest, most hilariously lopsided presidential election since our country was, a country. And so with that one, it was just automobiles and telephone subscribers are not people struggling in that year in the 1930s during the Great Depression. Those weren't the people driving around and then going home and ringing up their buddies. Those weren't the people struggling with the Depression. And I mean, just like today, there are people struggling with the economic collapse and there are people thriving on it. I mean, look at Amazon stock. It's just skyrocketing. Jeff Bezos loves this. And I don't know if he does. He probably does though. But representative sampling, how it applies to you, most of you, health and exercise science, a school with a PT program, and we have the pre-PT kind of pathway is housed in this department. Most of you are going into some form of clinical care, working with patients, or maybe working with athletes, whether it's MD, DO, nursing, occupational therapy, physical therapy, whatever you're going into. You're going to be working with patients. Now, most of these studies, they just do them on college students, right? I said that before. We all, professors are largely your researchers in life. And I mean, there are some peer researchers who just go into private practice and they go into industry and do industry funded research. But professors really do the bulk of research. And we just recruit students. I do. I use students. If I'm going to test Proteus or something like that, I round up a bunch of students. I don't go door to door in the community and then like, okay, let me try to get a representative sample. Let me do some people in Idaho and let me go out to Michigan. Like, I don't know. I just go get our students. I'll give you a point of extra credit. That's sort of what everybody does. And so this idea of representative sampling if you test a student and say, this program works, right? Whatever it is, it's some I don't know what the hell they're doing there, but some shoulder or tricep thing or whatever. And they test it on a 19-year-old healthy, recreationally active student, and then they go apply it to this guy who's 70 years old. Right? That's not representative sampling. That's Roosevelt destroying Alf Landon. But there's potential consequences here. So we have to understand how representative sampling works in a health environment as well. And you should try to manage all of your internal validity problems as much as possible. And we'll talk about some of those right now of what those can look like. So subject adherence, not everybody adheres. And the best way of medications, I talked about this earlier with cardiovascular medications, and people consider 80% adherence to be very compliant. These are the best patients. They're taking their medication 80% of the time. So think about pregnancy. Right. So think about birth control and, I'm on the pill and what people will say about how effective this thing is. I was on the pill and I still got pregnant. Okay. Yeah, you can do that if you mess up your doses. Now, once in a very, very rare occasion, Somebody will become pregnant while on birth control, but these are, practically miraculous. The pill works really well, but people don't really take it. 30% of women who are on the pill are missing doses. And so when you see stuff like this, typical use, the pill, it's like 93% effective. Yeah, it's like 100% effective if you actually take it. Again, I'm saying there are exceptions in the world, but those exceptions are scarce. And so it's just a matter of subject adherence. People don't do what you want them to do. Now, earlier in this lecture, I mentioned outliers, where we have subjects who perform really weird. So let's say this is study time down here, 180 minutes or hours or days or whatever of studying. Let's say 180 minutes a day of studying versus 60 minutes a day of studying. And this is your percentage on the test. And the more people study, typically the better they do, right? It's not exactly a linear relationship because there's diminishing returns, that studying from 150 to 180 minutes, okay, you've got a lot of studying, and early on you study a little bit and you get a massive improvement. That's sort of how it works. But then you have these outliers. This person scored really well with studying very little. This person scored yeah, I don't know, not that well, a 65 or something like that, but study for 2 hours. And so we have outliers. It's you can just look at it and know that they're outliers, but you have to come up, if you're just going to eliminate them from the analysis, so you can come up with a nice regression line to say, with each additional hour you spend studying, your grade is going to increase, whatever. You have to do that very systematically. You can't just look at people and go, no, I don't like that one. That one doesn't agree with my findings, because that's how people do their Cirque du Soleil and find that contortionists eliciting of a statistical finding. That's the sneaky way of doing it. What you want to do is come up with your method of managing outliers ahead of time. So that way the reader knows that it's not just a bunch of bias where you just eliminated the subjects because X, Y, and Z. Now, sometimes you'll find outliers that you didn't expect and you couldn't have anticipated, but what you can do is manage them by residuals. That's, if I make a little regression line, there's a regression line that goes through here. That's the residual is the vertical distance to the prediction. So the predicted line, this would be a simple linear regression. We have study minutes predicting exam score, and with each additional minute, right, we'd have this linear regression. It's not quite linear there, but the residual would be this distance to that line. And that line of best fit is what it's called in the regression. You get a line of best fit. It's trying to show you this visual prediction, and coming up with some distance of the residual or something like that. Is this an example of GIGO, deleting outliers? Sort of. GIGO is sort of the garbage out end. So you might get great data collected, and people are just weird. LeBron James is an outlier. I mean, there are athletes and geniuses and whatever who are just outliers. There's a great Malcolm Gladwell book called Outliers, who he sort of describes how they're formed. He's taken out of context a lot with the 10,000 hour rule, but that's sort of what people remember from that book, and like, that's not what that's about. But good book, The Outliers. About it has a lot of content in what developed, you're the Beatles or something, and what creates the Beatles. And outliers you're going to encounter. There are responders and non-responders to every drug and every exercise. Some people can just load up on a heroin and be normal, right? They're just functioning. Some people, their alcohol tolerance is huge, right? Andre the Giant, Google Andre the Giant alcohol or Andre the Giant beer or something. That guy's records of liquor consumption. It was outrageous. And so you're going to encounter outliers, but the garbage out piece, you're going to get garbage out if you're just sort of mutating your statistics. So yeah, again, delete your outliers accordingly. I was just reading the comments. So significance, as we've been talking about, significance does not confirm your finding. It does not state absolutely my finding is true, because it doesn't consider confounding variables. It doesn't consider quality of assessment, the administrators, the equipment. It considers none of those things. GIGO on the entering end, the garbage end, the p-value cannot address any of that stuff. So think about drug testing. If you're drug testing athletes, okay, well, what are you testing them for? How long is that thing going to last? Are they is it someone else's pee, right? So the assessments of somebody's clean record, this is invalid if you're not getting a good sample. Watch the pee coming out, and test them at the right time, right? So it depends what you're testing for. If you have a history of drug abuse, and your liver is a mess, you may have been clean for a while, and it's going to not exhibit that in the test. The actual test is still going to say you're on drugs because you can't process it as effectively. So the p-value doesn't say anything about that. The p-value just tells you statistical probabilities. Alcohol detection, right? You better detect them at the right time. That thing is changing all the time. It's going up, it's going up, it's going up. The drinker feels great, feels great, feels great. It's going down, it's going down, it's going down. The drinker feels horrible, feels horrible, feels horrible. Is depressed and whatever, sleepy. And it depends what time you test them, right? That's going to come and go, those numbers. And if you're looking at the effect of alcohol inebriation on some outcome, and you test them at the wrong time, your data are bad, because you're not that's the same thing as having someone hop on a scale that's not calibrated. It says they're give or take 10 pounds from what they actually are. So all of the carbon monoxide reading for cigarette smoking, same thing. You have to do this all the time. If somebody has to prove that they have quit smoking, you have to test them all the time. I mean, these things aren't going to linger. I mean, maybe you could just smell their fingers or something, but your testing, there's so much room for error in all of these things. Sometimes accidental bias sneaks in. So with me, and hopefully with all of you, we're all going to have accidental bias. We're not going to consider every confounding variable. Not every experiment I do is perfect. There's things I don't think of. Sometimes afterward, I'll do an ACSM project or something after. I'm like, oh, I didn't think of. And the really helpful part of presenting an ACSM poster, you show up, you're live, you have all of your analyses and findings, and everything is totally done. And someone comes up to you and says, did you ever think about, and you're like, no, it's obvious I should have, but and so you can go back to your SPSS, the figurative drawing board, and rerun analyses and try to control for things if you're capable, and then put the manuscript out after that. But everyone, there's accidents happen all the time. Spilled milk exists everywhere in the world. It exists in statistics, in every domain of athletics, and as a professor, I'll get to the end of a lecture like, oh, you know what I should have said? Like everybody, the accidents are abundant. Accidents abound in life, and that's okay. You want to be as thoughtful as you can. You want to spend as much time thinking through an experiment as you can to eliminate those sort of accidental, to eliminate ignorance. But we all have it. Me, you, we're all ignorant. Now, human error, there's also mistakes that we make that maybe we don't know we're making. So again, accidents exist. This is an example, one of my favorite examples in the literature of human error, where this is in Science. That's one of the top journals in the world. Came out in 2002. Severe dopaminergic neurotoxicity in primates after a common recreational dose of MDMA, or Molly. And so what they're saying is that if you do MDMA, you do ecstasy, Molly, whatever you call it, then you're going to get this sort of precursor for Parkinson's disease. So go to the dance party and just hang with me. If you're like, oh shit, I did Molly like last night, hang with me. It might not end with that same finding. So like, okay, so I do, let's say, this drug, and then I don't get all the cool movies, and I still wind up with Parkinson's. And so this is a big finding, right? This says that we may have people participating in an activity that is worse for their health than they think, than we previously thought, than anyone previously thought. What a big finding. Huge findings like this are publishable in journals like Science and Nature and New England Journal of Medicine. Huge findings like this they're interesting. And so the 5 squirrel monkeys, and the goal was, quote, to evaluate the neurotoxic potential of a dose regimen modeled closely after one often used by MDMA users at all-night dance parties. So this is the dose. I don't know what that equates to. And so we're just assuming all these people are dancing and this little kid is too. He's dancing too. Now, so they give these monkeys MDMA and one of them dies. I mean, pretty swift death, and another one is right on that verge of dying, right? Walking death, plank after the second dose, wasn't given the third dose, and all of them, I mean, the survivors, you evaluate them a couple weeks later, and they all have these nervous system problems, neurotransmitter problems. And this was not expected, right? If they were taking amphetamine at that dose, not like, oh, I did, my prescription of Adderall, but if they're doing amphetamine at a level of this dose, then like, yeah, maybe we would see this, but man, not with ecstasy. We should repeat this experiment, right? So they did that. They repeated the experiment on baboons, and one of them died after the second dose. And they had, it's like the same findings as with the monkeys, one near death, and the survivors, everybody demonstrates the same thing. So, wow, MDMA, this is huge. So what they report, let's just read this last little bit. The present findings challenge the commonly held notion that MDMA is a selective brain serotonin neurotoxin and carry important public health and scientific implications. Now, the problem is that they didn't know they didn't have ecstasy. They were giving them amphetamine, and they did 2 studies. So Science retracted the article. It's no longer valid. Now, you can still find it online, and that's helpful because it's useful information to know. Here's a lethal dose of amphetamine. That's useful information. Now, that wouldn't get into Science. That wouldn't get approved by an IRB. That study wouldn't have been done, but it was done accidentally. That wasn't on purpose. These scientists are embarrassed to have made this giant mistake and had their research very publicly retract and get all this criticism. But it's a useful study, and they just that was a mistake. They didn't mean to make that mistake. Now, some people make mistakes, and mistakes are forgivable unless you just make them all the time because you don't care, and you're just like, oh, we'll just put everyone in harm's way just because I'm tired and lazy. Now we have ethical problems, but if you tried and you messed up, nobody cares. The people who do care in that situation are the assholes. So, but this, talking of assholes, this Alex Avery, this guy, he works at a think tank, which is it's more marketing usually. There's not as many think tanks in government. You guys have heard this term before. It's more private sector stuff and a little bit of research, right? You strategize, maybe advocacy for something. That's what a think tank is doing. So this guy works at a think tank, and he's talking about Rachel Carson syndrome. Now, Rachel Carson, she wrote that book, Silent Spring, one of the most important books of the 20th century. If you open up some canon of literature in the 20th century, Silent Spring will be in there. Rachel Carson, she worked for the Fish and Wildlife Service, did a bunch of research and published that research, and then published the book. And from that, she wasn't the only inspiration, but that was the major movement to found the Environmental Protection Agency. She was one of these kind of big voices that got the EPA founded. And so this guy publishes this article, Rachel Carson syndrome, jumping to pesticide conclusions in the global frog crisis. Now, I'm going to read some of this because you don't need to know this exact situation, but contamination bias and deliberate bias, this is a little narrative to illustrate this phenomenon, which is just rampant in the literature. For years, some ecologists have been convinced that pesticides are contributing to a decline in amphibian species around the globe, from an apparent epidemic of deformed frogs in Minnesota to the near disappearance of yellow-legged frogs from California, Sierra Nevada mountains. Pesticides have been considered prime suspects. These are like, you can just Google pictures like this. I mean, they're like mutants. And not mutants in a cool, they're not like Teenage Mutant Ninja Turtles. They're not like mutants in a cool way. They look like that on the last side. There's Silent Spring, that's Rich Carson's book. This suspicion is no doubt rooted in the belief by the ecological community that the agricultural pesticide DDT, this thing down here, was responsible for a serious decline in raptor bird populations in North America after World War II, a theory popularized by this book. So he's still not even believing that DDT was bad. And so this is an article, it's 1962 New York Times, and it begins. So this just tells you the pesticide industry up in arms over a new book, right? Pesticides, private sector, tons of money. And so 1962, the $300 million pesticides industry has been highly irritated by, so already, this is in the 60s, and we have an industry that's $300 million. And so figure out those digits today. I mean, it's enormous, the pesticide industry. There are so many dollars to be won through pesticides and so many dollars to be lost when somebody does research and says they're causing problems. So over the past decade, tens of millions of dollars have been spent looking for the offending chemical or chemicals, in this like frog stuff. Yet time after time, no evidence has been found that pesticides are involved. 4 high-profile case studies, blah, blah, blah. There are at least 10,000 lakes in the High Sierra. 90% to 95% of them hold induced species of trout, but no more frogs at all. And there may be 200 lakes that have plenty of frogs, but fewer no fish. So the answer is pretty straightforward, and it doesn't get much simpler. Pretty bold claims. With no trout, you get an immediate and dramatic response. The threatened frogs return, and some of High Sierra's natural biodiversity returns too. Unfortunately, none of the research demonstrating the overwhelming impact of trout has changed the anti-pesticide mantra of researchers and environmental groups. So he's blaming trout here. And then all of these deformities, what he's blaming is calcium. He's like, oh, just natural lack of calcium. That's why this happened all of a sudden. So he concludes, the question is, how long will we allow public policy to be led by innuendo and flawed theories from the past? How long will the ecological research agenda be driven by unsupported scares that distract from real ecological threats? When will ecology become a science again? Okay, this is why it's such an asshole. So let's look at actual research. This guy's a stud. So he's at Berkeley, Integrative Biology Department. And so just, a couple hours away from us. And great article where he was looking at specifically the atrazine stuff. So DDT, right, this is banned in 1972. Atrazine is what replaced it. Atrazine is this incredibly abundant pesticide. So that's what, on your corn and everything, that's what we're all eating. And so the primary consumer being the US. So you go to the S-Mart or whatever and get your produce and stuff. So this is what you're eating. And low doses of atrazine, when you run the experiments, they feminize male amphibian. All males essentially become females of the frogs. And it's aromatase enzyme upregulating is what it does, where testosterone, it just gets converted into estrogens. It's really, in 147, I teach this cascade of how you get to testosterone. It all comes from cholesterol. These are steroid hormones. They're all synthesized from cholesterol. You can go from dehydroepiandrosterone to androstenedione to testosterone. Go ahead and convert that to estrogen, convert to estradiol. That's aromatase enzymes, and atrazine does that. So if now in a person, you're going to eat a lot of it to get an enormous effect, but in a frog, the frog doesn't need that much to get the effect. And so a bunch of industry-funded research comes out that says, oh, crap, people are finding that our pesticides are just horrible, right? These things are terrible. So we need to do some of our own research. Let's pay people. Let's buy researchers, pay them a lot of money, and have them conduct experiments. Now, these experiments never really get published because they're so bad, right? So they're reviewed, and then they're like, no, please, this isn't going to pass the peer review process. This is horrible, right? But the EPA, you can find them on the EPA. So if you look up this one, that's all you have to Google, and you can find this one. And this study, funded by the manufacturer of atrazine, was unable to find mortality differences between atrazine-exposed frogs and control frogs that weren't exposed to atrazine, nor were they able to find endocrine dysfunction in the males. So again, deliberate error, keep that in mind. So their conclusion was atrazine has no negative effects. All you environmentalists are a bunch of sissies, right? You're hindering the economy, and you're just bitching about whether it's global warming or whatever. You're just like a bunch of sissies. That's what they're saying. And so let us spray everything. But this is what they found. This is why it never got published. Here's mortality rate of these frogs. 0, control group. Okay, look at that mortality rate during the course of the study. Okay, add a little bit of atrazine, the mortality like goes down a little bit. Add a bunch more atrazine. I mean, that's like 90% mortality rate. Now, it's approaching an 80% average mortality rate of all frogs across the whole treatment. When you run an experiment that's not funded by the pesticide industry and you hit 15% mortality, something has gone terribly wrong and you shut down the experiment. Right? Mortality doesn't exceed 10%. I mean, this is if you hit 15%, something's wrong. 76.5% mortality is what they found. So the problems here, I think you guys have already figured this out, like who's being exposed to atrazine. Well, all of them. Right? All of them are being exposed to atrazine. They're lying. And so when you look at this is from the Tyrone Hayes article. When you look at an actual non-industry funded study, testosterone in males, it's like normal. Okay, atrazine males, you're like not guys anymore. Control as defined by whatever testosterone counts. Females, you end up getting control females. The guys have less testosterone than the control counterpart females. Now, do the atrazine funded research, and that's what you see. Control males, well, they're the same as the females to begin with, right? Add a bunch of atrazine and like nothing really changes because you've already eliminated all their testosterone. And so this is industry funded. This is non-industry funded. So again, what's happening? Why are these control males? Why are 80% of the control males dying and all of them have female levels of testosterone? Why is that the case? And so, and in both, in every single treatment group, right? Hermes doesn't say Hermes. Aphrodite stays Aphrodite, but all Hermes become hermaphrodites. And adding, dihydrotestosterone, if you add additional androgens, you're not seeing a raise in androgen levels. And so the reason this was reported, the reason for this problem was reported, and what it was they just don't even, on the terrariums, they don't even put lids on them. That's what the industry funded research does. It is so ludicrous, but this is one of those, I hate the cliche, quote, you can't make this stuff up. Everyone knows that cliche. I never use it. It's terrible. But that's what happens in industry funded research. It's so hilariously, not all of it. I mean, with the pesticides and stuff it is. But yeah, it's the comment that it's the dollar. You follow the dollar. How many dollars are in this industry? Follow the dollar. As soon as somebody does industry funded research, I mean, when Tyrone Hayes comes out with his articles, you just expect there to be, like a bounty on his head. Like, there are going to be some assassins here and there for political figures and maybe for Tyrone Hayes because he's costing so much money. Now, I did an incredibly honest abstract at ACSM. I mentioned this before for equipment that we have here in athletics, and the CEO, I mean, I was right on the verge of him suing me. And I'm just like, what are you going to, it's perfect research. I mean, I put in my QQ plots. I put in everything knowing how much hostility would come because I'm costing this person a ton of money. Because businesses are just like, I don't want this thing. Look at the research. The research says it doesn't do anything. And what it is predicting says the opposite. So I'm going to say honest things. And now sometimes I'm going to make an error, right? We all make errors from time to time. But I'm going to do the best I can to be honest. And when industry, I'm not going to accept $1 from industry. It's just, I don't know how I would sleep. I have such sleeping problems anyway. I don't need to add a horrible ethical constitution to it. So if you look here, this is industry funded research. This is the manufacturer, right? So we're looking at as industry funded as it gets. Does it affect gonads? No. Yes and no, maybe circumstantially, whatever. Industry funded research, right? The manufacturer of atrazine, they paid people to do their experiments and they found that it didn't have an effect. Look at every other experiment that's ever been done, right? This is not industry funded. These are private investigators who do not have $1 invested. Yes. What do you do with that information? Industry funded research, while it is not absolutely bad, if you're being paid to come up with a finding, how likely is it that you think you'll come up with the opposite finding? And you can do anything, just don't put lids on the terrariums. There's a comment. Sparta charges $1,000 a month for people to train, and as Jesse's comment, that Sparta is what I what I said. Like, this doesn't do anything. But maybe I'll put the email exchange in the actual slideshow, so you can just see what I put the poster in. It's a basketball one. It's at the start. I'll put the poster and maybe the email exchange in, and I'll definitely be sued at that point. So the p-value doesn't tell you everything, and but if you fail to control these variables, if you fail to be thoughtful and you fail, and if you just come up with whatever finding, Frank Wilczek, he's a Nobel laureate physicist, and his analogy that he talks about, the way people talk about string theory, he's like, okay, take a dart, throw it against the wall, walk up to that wall, and draw a bullseye around it. Right? That's it. It's a really clever, witty way of describing string theory. And I'm not a physicist, and I just hear string theory and I think, oh, cute, whatever. I've watched a couple Nova programs and I understand no more than I did when I was an infant. But this his theory about this description. This is what so many people do. They have their finding, whether it's here's what I'm just gonna go draw a bullseye around anything, right? That's what people do. They are so precious with their finding. They defend it like a lawyer, right? They're just sort of litigious with their finding. They defend it and but they might have taken on a murderer as a client and they're defending them. And so that's sort of the problem with a lot of the research. And what you want to avoid doing, you want to be as ethical as possible. And ethics don't get you very far. I mean, just go rob a bank and sell drugs and whatever, and you'll make way more money than I ever will, right? Ethics, if you try to be ethical in life, you take a huge pay cut. And in research, it's the same thing. If you're ethical, you take a pay cut. In sports, I mean, I don't think steroids are unethical, but I talk about that in 147, it's like the victim is oneself. But let's say, for the sake of the argument, let's say steroids, an unethical thing to do in sports, and there's lots of arguments and we can go over them, and we're not going to, but you're going to make more money that way. Like, so why do people behave unethically? There's a lot of money behind it. And so I understand it, but it's better to be impoverished and sort of hovering above the poverty line and living in an apartment or a house you don't quite love than being an asshole ruining the world. So that's the end of there's something of a pep talk in there, along with go make less money in life is really what I'm saying. All right, that's all I have for today. I think this is like early, huh?
Yeah, it's pretty early.
All right. Merry Christmas or whatever. Happy birthday.
Record time.
I hope you guys have. You feel free to leave if you want right now. I'll just answer some questions for those who stick around. But I hope people are done with classes now and can get off to fall break, a little recuperation.
I do have a question.
Yes.
Sorry, just to make sure for the project. So, would a good question be something like how has quarantine affected people's like workout routines? Would that be a good one?
Good. I like that. No, that's really good because I actually want to know. And if people have, but you want to get a bunch of responses. And so it would be very qualitative right there. Mm-hmm. If you have something like, what was your weight before? What's your weight after?
I was going to do more like, what was the amount of time and like what exercises did you do and what do you do now?
Yeah. Okay? I like the idea because what do people do? I mean, like I got a pull-up bar in my backyard. I don't know. What do people do? Mm-hmm. And I like the question. What I would do is start coming up with lists of things, lists of questions that you would ask. Did you have a gym membership before? Do you participate in a sport? How many years have you been exercising? Whatever, months, years. And so come up with a lot of behaviors and as many sort of measurable, dependent variable-y things that you can, sort of quantifications of things that you can as well. So not just open-ended questions, because open-ended questions, we'll talk about this for one day, because I'm not really into qualitative research, but we'll talk about qualitative research for one day about how to code responses. So you ask people open-ended questions and you code everything they say. And it takes a long time. And well, this person mentioned this theme, and so 4 times, and this person mentioned that same theme twice, but this theme once, and you sort of code these themes. And that's so time consuming, and nobody ever like it's like impossible to get published. So it's just improbable to get published. It's difficult to get published. So the more things you can quantify in that, the fewer open-ended questions, the better. Really be
Okay,
close-ended in your questions.
got
Yeses
it.
and nos and numbers and stuff like that.
Okay.
I like the topic though.
Thank you.
Yeah.
Uh,
Anyone else have any questions or comments or needs of some sort?
oh, actually, is it okay if we email you questions? Like, if we have questions about like how we're supposed to like
Yeah. Phrase
phrase
things and
things, or
yeah, of
yes.
course. Yeah, just send me an email. And some days I'm quicker than others on response time. So if you don't hear from me, if it's been 48 hours and you don't hear from me, just forward me the same message again so it's at the top of my inbox. I often get back to people the same day. I try to. Some days it's just all day long, and I'm like, ah. And um, if I'm sitting at my computer and a happens, I try to write back immediately. But if it's been 48 hours and I haven't responded, like I've just forgotten and it got pushed down and I'm not seeing it. But yeah, email me and I'll get back to you, and hopefully within like 12 hours
Okay.
is my plan and goal, and usually what I'm able to do.
All right. Thank you, Professor Jensen.
Yeah,
Goodbye.
yeah. All right. I assume everyone's on the way out now. Go enjoy your breaks.
Thank you.
Thank you.